See, this question we have to do it by maximum power. For maximum power, we'll have two conditions. RL is equal to RTH and maximum power formula is V square TH over 4RL. So here in this question, we need to calculate RL, right? So can we say that RL must be equal to RTH? Yes or no? This is your university exam question only. So RL, for calculation of RL, what we need to do? We need to sort the voltage source, and if there is a current source, then current source must be open or short? Open. Now from this diagram, can we get the value for RTH? So this is A, B, 2, 3, 6, right? So how can we get RAB or RTH? Tell me. From where we'll start? 2 ohm or 6 ohm? So in this case 2 is parallel with 3 because both are at the different path. That will combine it with 6 ohm, right? Now we from here after solving we'll get RTH and that would be equal to RL. Now in the next case they are asking you to calculate maximum power. Now as I told you earlier that what is the formula for the maximum power? V square TH by 4RL means Thevenin voltage ka square divided by 4RL, right? So now we need to calculate VTH, right? Because RTH we already have or RL we already have. Now we need to get VTH. Tell me how can we get VTH? This is A. So now we need to get ICD and ICD is equal to I2, right? So for ICD we have make two mesh equation. From here we can get the value for I2. We can substitute it here. Then we'll be able to get the value for VTH, right? And we can substitute the value for VTH over here. And then we already calculated RL in the previous case. Then after that we can get maximum power. Maximum power. Okay. Maximum power. So basically what you have studied in case of maximum power transfer theorem, ultimately you need to calculate RTH as we have done in the Thevenin and you need to calculate VTH as we have done in the Thevenin, correct? So you should know VTH and RTH calculation, then only you will be able to get the Thevenin theorem and maximum power transfer theorem, right? So whenever they'll give you the question for maximum, always calculate VTH and RTH and just put it in the formula. Okay, clear? Now after that, according to the syllabus, your next topic is superposition theorem, right? Do you know about the superposition theorem? Next topic is superposition theorem. Superposition theorem, in superposition theorem will have only one source at a time. Okay, one source at a time means like suppose this is the case. In this case, tell me how many sources are there? There are three sources. Two are the voltage source, 5 volt and 10 volt, right? And 2 ampere is the current source. So if there are three sources, this question will be solved in three different steps. Step number 1, step number 2 and step number 3. Clear? In the step number 1, we'll keep first voltage source and kill all other source. Okay? Keep first, and in second, keep second source, and in third, keep third source. Okay? Only. And how can we eliminate? Voltage source must be short circuit. Okay, as we have done in Thevenin also now, that if there is a voltage source, that must be short circuit, and current source must be open or short? Open circuit, right? Current source must be open circuit. So keep first source means 5-volt source, current source is open, and voltage source must be short. Keep second source means voltage source must be short, keep current source second source, and this one also short. Keep third source means we have to take the third source and eliminate all this. Understood? Now suppose here they want to calculate, they ask us to calculate the current in 3 ohm. So marked it here as I, that would be I dash, that would be I double dash, and that would be I triple dash. Okay? This is 5, 3, 6, 3, 6, 2, 3, 6, 10. Now your ultimate aim is to calculate I dash, I double dash, and I triple dash. Okay? And you need to calculate final I. So I would be always equal to I dash plus I double dash plus I triple dash. Fine? So as you have seen that I dash, I double dash, and I triple dash, all direction are same. That's why the current will add with each other. If they are opposite, then we need to subtract with each other. Like, don't consider the opposite case, don't take the opposite direction, always prefer to take in the same direction. Now calculate I dash. Now see, after solving first mesh, you will get I dash as 5 by 9, right? And after solving second step, this is the current source. So one equation you have make it from the current source, and one equation you need to make it from the super mesh. So this is the super mesh equation. After solving, you will get I double dash is this one, correct? Now for the third step, I triple dash, you make the simple mesh equation and you will get the value of I triple dash as this one. So finally you need I would be equal to I dash plus I double dash plus I triple dash. If I triple dash, we got it as minus 10 by 9, so put minus 10 by 9 only. Okay, don't convert it into plus by your own. Here you are getting minus 2 by 9, so minus 2 by 9. Here you are getting plus 5 by 9, so put it as plus 5 by 9. After solving, you will get the final answer. Understood? See, in this case also we need to apply superposition theorem. So we have to take the first source. Yes. Okay. 12 volt. In the first step, we have taken first source. Remove other source. In the second step, we have taken second source, right? Remove all other sources. In the third step, we have taken third source and remove other sources. They ask you to calculate current in I. So we have marked I dash, I double dash, and I triple dash, right? So mark it as I1, I2, 2 mesh. In this, how many meshes? 3 meshes. I1, I2, I3. Similarly, I1, no, I2. So now you need to solve it, right? Here I dash is equal to I1 because no other current is flowing in this. Here I double dash is equal to I1 minus I2. I1 is also moving down, I double dash is also moving down. Here I triple dash is equal to I1 again because no current is flowing. Yes or no? Now after this, I hope you will solve it. We'll move towards the next topic, that is source transformation, right? As this topic is not mentioned in your syllabus, but question will come in your exam from this topic, right? So source transformation means source conversion. We can have current source and we can convert it into voltage source. Okay. Similarly, we can have voltage source, we can convert it into current source, right? But there is one condition. What was that condition? That current source must be connected in parallel with the resistance. If current source is connected in series with the resistance, then in that case we can't convert, right? So the same resistance which is connected in parallel would be connected to the series with the voltage source. Okay, like 5 ohm they have connected, 5 ohm only we need to connect it. Here we need to calculate the value for voltage. V is equal to I into R. So I is how much? 10 ampere. Resistance is how much? 5. So that would be 50 volt. Clear? Now in this case, see, I have taken the same value 50 and 5. We need to convert this voltage source into the current source, right? So this resistance which is in series, same resistance would be converted into parallel 5. Now we need to calculate current. I is equal to V over R. V is 50 by 5. That would be 10 ampere. Okay. Note it down. Now the last topic of your first unit is star delta transformation. This one. All other topics are completed, only star delta is left. Now star delta will study in detail, like we'll have three phase circuit, and in three phase circuit we'll have three different types of wire. Okay, one is R, another is Y, another is B, blue. R for red, Y for yellow, B for blue. So three phase, three wires is divided into further two category. One is the star connection. Star connection can be of this kind: red, R, yellow and blue. Like they can connect it with a single point. Okay. Next one is the delta connected. Delta connected means wire can be connected like this: red, yellow and blue. Okay, clear? So now we can convert star to delta and delta to star. Let's see how. Like we'll have this one as a delta, right? And this one would be converted, star is like this. So this is consider RA, this you can consider as RB, this you can consider as RC. This one is R1, this one is R2, this one is R3. First you need to learn about the formulas of delta to star conversion. Delta to star means delta is like this, right? R1, R2, R3, and you need to convert it into star. So which value you need? RA, RB, RC or R1, R2, R3? RA, RB, RC, right? Now as you can see that RA is connected between R1 and R2, है ना? So what is the formula? R1 into R2 divided by sum of all, R1 plus R2 plus R3. Okay. Now RB is connected with R2 and R3. So RB is R1 plus R2 plus R3. RC is connected with R1 and R3. So R1, easy. Next we need to learn about star to delta. For star we need R1, R2, R3, right? So R1 is connected with RC and RA. So it would be RA plus RC plus RA into RC divided by the rest RB. Okay. Now R2 is connected between RA and RB. And R3 is connected to okay. So these formulas you need to remember. Got it? Now see, this is the question from your question paper only, VIT. Maximum power transfer theorem, that is your homework. Above one is based on star and delta. Okay. It is of 10 marks question. It is from end term exam. So how can we calculate it through star and delta? As you can see, we need to calculate across A and B, right? As you can see that it looks like delta. So if it look like delta, can we convert it into star? So it's a delta to star, right? Rest of 20, yeah, 25, 15, right? If I'll convert it into star, it would look like this. So this value is how much? 20 into 5 divided by sum means 40. This value is how much? 20 into 15 by 40. And this value is how much? 5 into 15 over 40. Okay. Now I'll redraw the diagram. 10 ohm as it is. This one will become this one and like this. 5 ohm as it is, right? This 10 and 5 will become 15 because they both are in series. Similarly, this 25 and 5, they are in series. It will become 30, right? Down one is also 30. This is A, B, right? So basically this is your star which we have converted. Rest of the things are same. 10, 10, 15, 15, and this one is 30, 30, this one is 30, 30, and this one is 2, right? So now you can simplify it. Again it will form this one resistance and this one resistance. They both are connected in series. Similarly, this one resistance and this one resistance, they both are connected in series. This one and this one, they both are connected in series. Now next diagram is like this. Yes or no? 15 ohm I shifted here. It's in series now. Okay, now it will again comma delta, right? Again you need to convert delta into char, then you can solve it easily. Now try this question in your homework. Okay.